In this video we will derive the expressions for the law of sine and cosine. The law of sines and the law of cosines are two fundamental trigonometric principles used to solve triangles, particularly in geometry and trigonometry. They help us find missing angles and side lengths in triangles when certain information is known. The law of cosines, also known as the cosine rule, is used to find the lengths of sides or the measures of angles in triangles, especially when you have information about side lengths and angles. It is more versatile than the law of sines and can be applied to all types of triangles, including right triangles. Here we have a triangle given its angles capitals A, B and C. The lengths are also indicated here with the small letters A, B, and C. Cutting through the angle is the line BD, which forms a right triangle with the angle D equal to 90 degrees. Consider first the angle A, where we see the cosine function of it is obtained and it is rewritten as a function of C times the cosine of A, getting an expression for the length CD. We have equation 1. The triangle BAD, we have the sine function of A and it shows the length BD equal to the C times the sine of A as shown in equation 2. Substituting the equation 1 and 2, we obtain the length A, which is obtained using the Pythagorean theorem. Substituting them, we see an expression for the relationship of the lengths as shown in equation 3. This is one of the three expressions for the law of sine. You can obtain the other expressions using a similar route. Here we have an example for the law of cosine. In this example, a triangle shown in the figure having its lengths as a given. You are then asked to find the angle A. So, using the previously derived expression shown in equation 3. Rewriting the expression, we see equation 4. Substituting the known values, we arrive to a value of about 111 degrees. Do not forget to set your devices to degree mode. The law of sines, also known as the sine rule, applies to any triangle, whether it's acute, obtuse, or right-angled. It relates the lengths of the sides of a triangle to the sines of their opposite angles. So, if we examine the segment lengths, we see that the segment AB is just C, segment BC is just A, and segment AC is just B. The angle BAD, we get an expression for sine C, which is just the ratio of H over C as shown in equation 5. For the angle BCD, we obtain an expression for the sine C, which is just the ratio of the length H over A as shown in equation 6. Now, taking the ratio of the sines, we have equation 7. Cross-multiplying the terms in equation 7, we arrive at equation 8, which is an expression for the law of sine. You can get the angle B relationship using a similar approach. Here we have an example for the sine function. We are given a triangle with its lengths and angles shown here, and we are asked to find the length C. So, using the expression we obtained earlier shown in equation 8, we rewrite it and obtain an equation solving for C. Substituting the known values, we obtain the length C, which is about 5.7 cm. Do not forget to set your devices to degree mode. The end for now. For questions and comments, you may send them to diyeslearningstuff@gmail.com. You may review the slide on YouTube at @dies_learningstuff. Note, please do not forget to use your school email. Also write your complete name and class section. Thank you for listening and see you next module.